All right, this is my third time starting this. I keep fumbling over my words. I'm not going to do it again, so forgive me if I fumble over my words again. A recent report stated that less than 35% of adult residents in a certain city will be able to pass a physical fitness test. Consequently, the city's recreation department is trying to convince the city council to fund more physical fitness programs. The council is facing budget constraints and is skeptical of the report. The council will fund more physical fitness programs only if the recreation department can provide convincing evidence the report is true. The rec department plans to collect data from a sample of 185 adult residents in the city. A test of significance will be conducted at a significance level of alpha equals 0.05. The following hypothesis is the null hypothesis is p is equal to 0.35. The alternative is p is less than 0.35, where p is the proportion of adult residents in the city who are able to pass the physical fitness test. All right. Describe what a type 2 error would be in the context of the study, and also describe a consequence of making this type of error. I think right now you should give yourself a brief review of a type 1, type 2, and power. Type 1 is where we reject the null hypothesis, and we shouldn't have. Type 2 is where we fail to reject the null hypothesis, and we shouldn't have. Power is where we reject the null hypothesis, and we should have. We did the right thing. A type 2 error in the context of this study would be we fail to reject the null hypothesis, and we have no evidence for HA that the true proportion is less than 0.35. As a result, the city does not fund more physical fitness programs. And then a consequence of that is people are missing out on an opportunity to get more fit. You may need to rewind because I'm not going to type this or write it down. It's just going to go faster if I can just talk through each problem. Part B. The Recreation Department recruits 185 adult residents who volunteer to take the physical fitness test. The test is passed by 77 of the 185 volunteers, resulting in a p-value of 0.97 for the hypotheses stated above. If it was reasonable to conduct a test of significance for the hypothesis stated above using the data collected from 185 volunteers, what would the p-value of 0.97 lead you to conclude? Now, it does not ask you to interpret the p-value. That is different than concluding about the p-value. The conclude is saying, because the p-value is 0.97, which is greater than alpha of 0.05, we fail to reject the null hypotheses. We have no evidence that the true proportion of adult residents in the city who are able to pass the physical fitness test is less than 0.35. Again, there's no math required of me here, so I'm not going to type anything out. Please rewind. I will type things out when there's math involved for you. Rewind so you can hear it again, and let me know if you have any questions. I think it's important to note, though, that you will be asked on interpreting a p-value question, and we've talked about this in class. A p-value is the probability of getting our statistic as extreme or more extreme than the one we calculated, given the null hypothesis is true. We have to state that part in context. So given that the true proportion of adult residents in the city who are able to pass the physical fitness test is 0.35. That will be on your test. It is not difficult if you memorize it. It should be an easy point for you to get. Part C says describe the primary flaw in the study described in Part B and explain why it is a concern. Well, they violated a condition, kind of, I guess. You can have volunteers, but if you have volunteers, then you need to make sure that it's a randomized comparative experiment to draw conclusions. So with that, we have some lurking variables involved. Let me talk about that on this page. Volunteers, what did they volunteer for? They volunteered for a fitness test. What did they measure? Well, they measured, whoops, I was going to do an arrow. Doesn't matter, I guess, but they measured how physically fit they were. The lurking variable involved here is people who volunteer for a fitness test are most likely into fitness. I don't know how to play piano very well. I am not going to volunteer for a study about playing the piano if I don't know how to play it very well. People who are really into fitness like to do fitness things. They run races or they go work out or whatever may be. They're more apt to volunteer for a fitness test for the city and take part of this observational study. That is the issue with Part C. So most likely, it's a concern because that 0.97 that p-value that they got, 0.97, 77 of the 185 volunteers, if you put that in your calculator, 77 divided by 185 is 0.41, which is actually above the 0.35, and they were hoping to find something below. Again, big concern, and it's a flaw in how they went about their observational study. Let me know if you have any questions. I could talk at more length about, well, what could they have done? They could have screened their participants more, made sure that they had kind of a more representative sample of the types of fitness abilities in the city, so on and so forth. But it doesn't ask that. Have a good day. Happy studying.